Hello and welcome back. So in this new video, I'm going to start a new course here, the one named Elastic Google Cloud Infrastructure, Scaling and Automation. But before starting, I will go to the leaderboard here. And let's see, we are in the Golden League. We have 5 days to collect as much points as possible. I would like to arrive to, well, I will for sure arrive at more than 2,000, and it will be nice to, to be like among top 5 users, so I can sleep without thinking that someone will surpass me. So my goal is to be promoted to the Diamond League. Therefore, let's start immediately. Let's have this course as straight as possible. It's a 20 credit course. Remember, I have a membership subscription which allows me to basically for $29 use I don't know how many credits, but yeah, I have like access to a lot of labs and many exercises, which in my case will be useful for the professional architect certification. In other cases, may be used for other certifications. There are a lot of paths you can find here in Cloud Skill Boosts. And yeah, you may just choose one and go for it. Therefore, let's start. So this course here is an on-demand course that introduces participants to the comprehensive and flexible infrastructure and platform services provided by Google Cloud. So in the video before, I've been practicing with the infrastructure, core services and foundation. Now I'll go for the scaling and automation aspects of the infrastructure that Google Cloud provides. Therefore, let's start with the first module, which is the introduction. I hope to not spend too much time on it.
Hello, I'm Philip Meyer.
And I'm Elaine Biddle. We're both course developers at Google Cloud, and we want to welcome you to Architecting with Compute Engine, a series of 3 courses.
Before we start using all of the different services that Google Cloud Platform or GCP offers, let's talk about what GCP is. When you look at Google Cloud, you'll see that it's actually part of a much larger ecosystem. This ecosystem
Okay, so in the videos before, I already had a look at
new regions, points of presence,
here.
and state-of-the-art software-defined networking and distributed systems technologies to host and deliver your services around the world. Now, from infrastructure, scaling, Google Cloud Platform.
This schema is really important as it explains you the type of solutions that Google Cloud provides. You have infrastructure as a service solutions, platform as a service solution, and software as a service solution. You can choose where to work, with which type of solutions you prefer to work. There are many ways to provide a solution for a certain type of necessity or problem you may have. Therefore, you just need to know all the differences and choose the right one that will give you more flexibility. Maybe you prefer to pay less. Who knows which are your use cases. Therefore, this is a really nice resource, visual resource. Then we have introduction about all the computing services. So in the foundation core services, we've had a look at these topics, and now we're starting this course, which will let us know how to interconnect networks, how to use load balancer and autoscaling, how to use infrastructure automations and managed services. Therefore, let's go. I will skip this document. It doesn't look really interesting.
Hi, I'm Priyanka
So
Vargadia,
my
a developer
dog here
advocate for
is
Google
having a
Cloud.
nightmare.
In this module, we focus on interconnecting networks.
He's vocalizing his nightmares. So let's go. So after introduction module, we have the interconnecting networks module, which has just one lab. So it may be doable in 40 minutes, the whole module. Yeah, we'll try it. Let's go.
Hi, I'm Priyanka Vargadia, a developer advocate for Google Cloud. In this module, we focus on interconnecting networks. Different applications and workloads require different network connectivity solutions. That is why Google supports multiple ways to connect your infrastructure to GCP. In this module, we'll focus on GCP's hybrid connectivity products, which are Cloud VPN, Cloud Interconnect, and peering. We'll also look at options for sharing VPC networks within GCP. Let's start by talking about Cloud VPN so that you can explore it in a lab.
Let's go.
Google Cloud offers two types of Cloud VPN gateways, Hey VVPN and Classic VPN. All Cloud VPN gateways created before the introduction of AK VPN are considered Classic VPN gateways. Classic VPN
We'll go slower because this looks like really interesting information.
Google Cloud offers two types of Cloud VPN gateways, Hey VVPN and Classic VPN. All Cloud VPN gateways created before the introduction of AK VPN are considered Classic VPN gateways. Classic VPN securely connects your on-premises network to your Google Cloud VPC network through an IPsec VPN tunnel. Traffic traveling between the two networks is encrypted by one VPN gateway, then decrypted by the other VPN gateway. This protects your data as it travels over the public internet, and that's why Classic VPN is useful for low-volume data connections. As a managed service, Classic VPN provides an SLA of 99.9% service availability and supports site-to-site VPN, static and dynamic routes, and IKEV1 and IKEV2 ciphers. Classic VPN doesn't support use cases where client computers need to dial in to a VPN using client VPN software. Also, dynamic routes are configured with Cloud Router, which we will cover briefly. For more information about this SLA and these features, please refer to the documentation link in the course resources for this module.
Let me walk you through an example of Cloud VPN. This diagram shows a classic VPN connection between your VPC and on-premise network. Your VPC network has subnets in US East 1 and US West 1, with Google Cloud resources in each of those regions. These resources are able to communicate using their internal IP addresses because routing within a network is automatically configured, assuming that firewall rules allow the communication. Now, in order to connect to your on-premise network and its resources, you need to configure your Cloud VPN gateway, on-premises VPN gateway, and two VPN tunnels.
So Cloud VPN gateway, on-premises VPN gateway, then VPN tunnel. Okay. And the second VPN tunnel, routing table, VPC routing.
Cloud VPN gateway is a regional resource that uses a regional external IP address. Your on-premises VPN gateway can be a physical device in your data center or a physical or software-based VPN offering in another cloud provider's network. This VPN gateway also has an external IP address. A VPN tunnel then connects your VPN gateways and serves as a virtual medium through which encrypted traffic is passed. In order to create a connection between two VPN gateways, you must establish two VPN tunnels. Each tunnel defines the connection from the perspective of its gateway, and traffic can only pass when the pair of tunnels is established. Now, One thing to remember when using Cloud VPN is that the maximum transmission unit, or MTU, for your on-premises VPN gateway cannot be greater than 1460 bytes. This is because of the encryption and encapsulation of packets. For more information about this MTU consideration, please refer to the documentation link in the course resources. In addition to classic VPN, Google Cloud also offers a second type of cloud VPN gateway, HAVPN. HAVPN is a high availability cloud VPN solution that lets you securely connect your on-premises network to your virtual private cloud network through an IPsec VPN connection in a single region. HAVPN provides an SLA of 99.99% service availability. To guarantee a 99.99% availability SLA for HAVPN connections, you must properly configure 2 or 4 tunnels from your HAVPN gateway to your peer VPN gateway or another HAVPN gateway. When you create an HAVPN gateway, Google Cloud automatically chooses 2 external IP addresses, one for each of its fixed number of 2 interfaces. Each IP address is automatically chosen from a unique address pool to support high availability. Each of the HAVPN gateway interfaces support multiple tunnels. You can also create multiple HAVPN gateways. When you delete the HAVPN gateway, Google Cloud releases the IP addresses for reuse. You can configure an HAVPN gateway with only one active interface and one external IP address. However, this configuration does not provide a 99.99% service availability SLA. VPN tunnels connected to HAVPN gateways must use dynamic routing. Depending on the way that you configure route priorities for HAVPN tunnels, you can create an active-active or active-passive routing configuration. HAVPN supports site-to-site VPN in one of the following recommended topologies or configuration scenarios: a HAVPN gateway to peer VPN devices, an HAVPN gateway to an Amazon Web Services virtual private gateway, 2 HAVPN gateways connected to each other. Let's explore these configurations in a bit more detail. There are 3 typical peer gateway configurations for HAVPN: an HAVPN gateway to 2 separate peer VPN devices, each with its own IP addresses, an HAVPN gateway to 1 peer VPN device that use 2 separate IP addresses, and an HAVPN gateway to 1 peer VPN device that use 1 IP address. Let's walk through an example. In this topology, one HAVPN gateway connects to 2 peer devices. Each peer device has 1 interface and 1 external IP address. The HAVPN gateway uses 2 tunnels, 1 tunnel to each peer device. If your peer-side gateway is hardware-based, having a second peer-side gateway provides redundancy and failover on that side of the connection. A second physical gateway lets you take one of the gateways offline for software updates or other scheduled maintenance. It also protects if there is a failure in one of these devices. In Google Cloud, the redundancy type for this configuration takes the value 2 IPS redundancy. The example shown here provides 99.99% availability. When configuring an HAVPN external VPN gateway to Amazon Web Services, you can use either a transit gateway or a virtual private gateway. Only the transit gateway transports equal cost multipath ECMP routing. When enabled, ECMP equally distributes traffic across active tunnels. Let's walk through an example. In this topology, there are 3 major gateway components to set up for this configuration: an HAVPN gateway in Google Cloud with 2 interfaces, 2 AWS virtual private gateways, which connects to a HAVPN gateway, and an external VPN gateway resource in Google Cloud that represents your AWS virtual private gateway. This resource provides information to Google Cloud about your AWS gateway. The supported AWS configuration uses a total of 4 tunnels. 2 tunnels from one AWS virtual private gateway to one interface of the HAVPN gateway, and 2 tunnels from the VPN gateway in each network.
Can I remember
the configuration shown provides 99.99% of
so.
on. To use dynamic routes, you need it allows for
something
in
with,
tunnels. Going
say some
in the
more
new
logic
an
instead
additional
of just
these 2 IP address
examples.
0.0/16. These addresses are not part of IP address space of either network and are used exclusively for establishing.
I need something that explains me why things are working in a certain way. So let's see, configuring Google
Let's apply what we
Cloud
just covered.
HAVPN.
In this lab, you created a global VPC called VPC demo with 2 custom subnets in US East 1 and US Central 1. In this VPC, you add a compute engine instance in each region. You then create a second VPC called on-prem to simulate a customer's
Let's go
on-premises
to the
data.
practice. So it's already 10 minutes of theory. Okay, there are a lot of tasks, and it's a topic which I don't know, so I will take at least 40 minutes. 40 minutes means this 15 and other 25, which means it will remain just 30 minutes of lab when I will finish, I hope. Let's go, let's see what happens here. So yeah, I understand. Let's see. Okay. Now, task one. So let's see, setup and requirements. Incognito window, yeah. Okay. Okay, yeah. In this task, you set up a global VPC with two custom subnets and two VM instances running in each zone. So create a network called VPC demo. Okay. Let's go. We create a network called VPC demo with subnet mode custom. In Cloud Shell, create subnet VPC demo subnet 1 in the region US East 4 with this command. So, okay, we have the VPC created. It's a regional with a IPv4 range. Okay. So it's a custom mode VPC. We need to define all these things here, like the firewall rules and the routes. Oh shit. So we're creating a subnet called VPC demo subnet 1 in the network VPC demo. And the IP ranges will be this one in the region US East 4. Create another subnet, US East 1, with similar characteristics and IP range, which is not overlapping with the previous one because they're in the same VPC network. Okay. Now create a firewall rule to allow all custom traffic within the network. Okay. Create a firewall rule to allow SSH and ICMP traffic from anywhere, which means also from outside. Create a VM instance, VPC demo instance 1 in zone US East 4B. Type will be E2 medium, create a VM instance, VPC demo instance 2 in US East 1, same type of machine. Okay, so this is the internal and external IP for the machine we just created. Now we'll get the other one. Okay, task 2. In this task, you create a VPC called on-prem that simulates an on-premises environment from where a customer connects to the workload environment. Workload networks create on-prem subnet mode custom. Okay. Okay, create a subnet called on-prem subnet 1. Taking a bit, kind of cold. Okay. Therefore, let me continue. Sorry. So we just created the on-prem. Now we will create this subnet. And then we proceed creating the firewall rules. Okay. And then the outside traffic. Okay, create an instance called on-prem instance 1 in the region US East 4. In the below command, replace with a zone in US East 4, but different from the one used to create the VPC demo instance 1 in the VPC demo subnet 1. Okay, so I need a zone name. A. Okay, now set up an HA VPN gateway on each cloud VPN gateway. So in this task, you create an HA VPN gateway in each VPC network, and then create an HA VPN create HA VPN tunnels on each cloud VPN gateway. In Cloud Shell, create an HA VPN in the VPC demo network. Okay, so understand that we will have this gateway in a specific region, in a specific network. create an HA VPN in the on-prem network. Okay, so now in the on-prem, we just create a VPN gateway. Okay, region is 4. View details for the VPC demo VPN gateway to verify the settings. So we're viewing the details for the first one, the one which is in the cloud in this hypothetical exercise. Describe this gateway from this region. You have the creation timestamp, gateway IP version, the name, network, region, self-link, and the two IP addresses which are necessary for some reason for the two tunnels. So then we can get the details for the other gateway. Okay. Now create cloud routers. So create a cloud router in the VPC demo network. So routers create VPC demo router 1 in this region, in this network with this standard. Okay, done. The output should look similar to this, and then create a cloud router in the on-prem network. Task 4, create 2 VPN tunnels. In this task, you create VPN tunnels between the two gateways. For each VPN setup, you add 2 tunnels from each gateway to the remote setup. You create a tunnel on interface 0 and connect to interface 0 on the remote gateway. Next, you create another tunnel on interface 1 and connect to interface 1 on the remote gateway. When you run HA VPN tunnels between the Google Cloud VPCs, you need to make sure that the tunnel on interface 0 is connected to interface 0 on the remote VPN gateway. Similarly, the tunnel on interface 1 must be connected to 1. Okay. In your own environment, if you run an HA VPN to a remote VPN gateway on premises for a customer, you can connect in one of the following ways. 2 on-premises VPN gateway devices. Each of the tunnels from each interface on the Cloud VPN gateway must be connected to its own peer gateway. A single on-premises VPN gateway device with 2 interfaces. Each of the tunnels from each interface on the Cloud VPN gateway must be connected to its own interface on the peer gateway. Single on-premise VPN gateway device with a single interface. Both of the tunnels from each interface on the Cloud VPN gateway must be connected to the same interface on the peer gateway. In this lab, you are simulating an on-premises setup with both VPN gateways in Google Cloud. You ensure that interface 0 create the first VPN tunnel in the VPC demo network. So create VPC demo tunnel peer GCP gateway. This will be the first gateway in this region. This is the key something security version. Okay. This shard secret, something that we have from before. Do we have a shard secret specified here? Strange. Okay, so to create a VPN tunnel, you specify to which gateway you want to connect. Through which router you want to move, and from which gateway you want to start. And yeah, interface 0. Interface 0 is this one. For the VPC demo gateway will be from this address to this address. But the shard circuit, what the fuck? Just a wow. It surprises me that it's working. Okay, peer address, and it's this one. Okay. Now we create the other VPC demo tunnel 1. So it's another tunnel from the cloud VPC to the on-premises network using the same router, but another interface. So now we're doing the reverse. So from the on-premise, we are creating a VPN tunnel to the demo VPC. Sorry, my voice is dying. I don't know what's happening. In this task, you configure BGP peering for each VPN tunnel between VPC demo and on-prem VPC. HAVPN requires dynamic routing to enable 99.99% availability. Create the router interface for tunnel 0 in network VPC demo. Add interface. Interface tunnel to on-prem. So it will use this VPN tunnel. Now create the BGP peer for tunnel 0. Using the interface we just defined. Then create a router interface for tunnel 1 in VPC demo. And then we create the BGP peer for tunnel 1. I'm not really sure what all these things are. I need to completely start studying them from completely zero. Create a route or interface for tunnel 0 on-prem. Okay. Create on-prem. I mean, I'm just launching commands in this lab. It's kind of cool, but at the same time, will I really remember all of this stuff? No. But I can say I did it one time. So I have a general idea about how it may work. But yeah, I need principles to understand things. So in this task, you verify the router configurations in both VPCs. You configure firewall roles to allow traffic between each VPC and verify the status of the tunnels. You also verify private connectivity over VPN between each VPC and enable global routing mode for the VPC. View details of Cloud Router VPC demo router 1 to verify its settings. Oh shit, there's a lot of information here. So, G-Cloud Computer Routers describe this router here. We have the BGP peers, interfaces. Okay. View details of Cloud Router on-prem router 1. So the same here. The output should like, okay. Configure firewall rules to allow traffic from the remote VPC. So allow traffic from the network VPC on-prem to VPC demo. Create VPC demo allow subnets from on-prem. So this is a firewall rule which will allow TCP, UDP, and SMP from these source ranges. Allow traffic from VPC demo to network on-prem, VPC on-prem. Okay. Verify the status of the tunnels. List the VPN tunnels you just created. So we created 4 tunnels. Verify that VPC demo tunnel 0 is up. Tunnel is up and running. Okay, verify that VPC demo tunnel 1 is up. Okay. Yeah, I mean, I think they're all up. Verify private connectivity over VPN. So now, from here, gcloud SSH to on-prem instance, zone name. From the instance, on-prem instance in network on-prem to reach instances in network VPC demo ping. Yeah. What? What the fuck? Ah. Oh, fuck me. So the zone is US. Yeah, so this is task 6. In task 2, I put instead of, oh, so it was US East 4 B. It was A, right? Yeah, great. So now let's get back here where we were continuing. Okay. Yeah. So we did SSH, now ping the other machine. Great, we successfully pinged. So global routing with VPN. HAVPN is a regional resource and cloud router that by default only sees the routes in the region in which it is deployed. Is a regional resource and cloud router that by default only sees the routes in which it is deployed. Okay, it's a statement which I'm not really sure if it's correctly written. I feel like I have a bit of flu in this moment, but let's continue. To reach instances in a different region than the cloud router, you need to enable global routing mode for the VPC. This allows the cloud router to see and advertise routes from other regions. Updates VPC network BGP routing mode global. Basically, yeah. Verify the change. What? Jesus, man. Oh my god, fuck me. I was launching the commands supposed to be launched from Cloud Shell. I was launching them from the on-premise instance. Now, yes, we have the right output. Okay, we SSH in the on-premise machine, and now we can ping again. Now we bring down, we delete this VPC demo tunnel. Yes. Verify that the tunnel is down. Tunnel is up and running. The dash status should show a handshake with peer broken. Okay, now yes, we have the expected behavior. Switch to the previous Cloud Shell tab that has the OpenSSH session running and verify the pings between. Okay. So now I SSH in the machine, the ping. Okay, so we're still successfully communicating with the other machine. Okay. Ping RC successful. So clean up lab environment. Delete VPN tunnels. I will not clean anything. It's just deleting resources with commands. I will not do this. Look here. Cloud Boost removes the resources you've used and cleans the account for you. Bye-bye. Okay. Yeah, I will put 4 stars. Boring. I mean, yeah, I understand that they allowed me to practice some command line commands, but I just pasted some commands here. I mean, it's not their fault. I just have to study this network architecture with HA VPN, understand that it's a VPN that requires the double tunnel. Let's see if it's right, my understanding. So classic, do you know that in GCP we have the classic VPN, cloud VPN, and HA VPN? Designed to address a use case. So a simpler VPN option primarily designed for basic use cases where high availability or multiple tunnels are not required. Single VPN tunnel per gateway, not designed for high availability or automatic failover. Managed VPN, but less robust compared to HA VPN. Suitable for non-critical application or proof of concept deployments where high availability is not a concern. 2 interfaces per VPN gateway, allowing for multiple tunnels and high availability. Border gateway control for dynamic routing. Okay. Wonderful. Now we can continue then.
Next, let's talk about the cloud interconnect and peering services. There are different cloud interconnect and peering services available to connect your infrastructure to.
Sorry, so normally we have a video of recapping. In this case, not. Okay.
Next, let's talk about the cloud interconnect and peering services. There are different cloud interconnect and peering services available to connect your infrastructure to Google's network. These services can be split into dedicated versus shared connections and layer 2 versus layer 3 connections. The services are direct peering, carrier peering, dedicated interconnect, and partner interconnect, which supports both layer 2.
So we have partner interconnect, dedicated interconnect, carrier peering, and direct peering. Dedicated versus shared, carrier peering and partner interconnect. So direct and dedicated, they explicit this as they are dedicated for just one customer of GCP. Okay. Layer 3, I imagine they work on IP or something like that. Here they're working on the connection directly.
And layer 3. Dedicated connections provide a direct connection to Google's network, but shared connections provide a connection to Google's network through a partner. Layer 2 connections use a VLAN that pipes directly into your GCP environment, providing connectivity to internal IP addresses in the RFC 1918 address space. Layer 3 connections provide access to Google Workspace Services, U2, and Google Cloud APIs using public IP addresses. Now, as explained earlier, Google also offers its own virtual private network service called Cloud VPN. This service uses the public internet, but traffic is encrypted and provides access to internal IP addresses. That's why Cloud VPN is a useful addition to direct peering and carrier peering. Let's explain the cloud interconnect and peering services separately first before discussing guidance on choosing the right connection.
Okay.
Dedicated interconnect provides direct physical connections between your on-premise network and Google's network. This enables you to transfer large amounts of data between networks, which can be more cost-effective than purchasing additional bandwidth over the public internet. In order to use dedicated interconnect, you need to provision a cross-connect between the Google network and your own router in a common co-location facility, as shown in this diagram. To exchange routes between the networks, you configure a BGP session over the interconnect between the cloud router and the on-premise router. This will allow user traffic from the on-premise network to reach GCP resources on the VPC network and vice versa. Dedicated interconnect can be configured to offer a 99.9% or a 99.99% uptime SLA. See the dedicated interconnect documentation for details on how to achieve these SLAs.
On-premises router, colocation facility, Google peering edge. Will then connect to the Google's cloud router. So you need to share with Google a colocation close to your on-premise network. Okay. So you find a place where Google can install the Google peering edge. For sure, they will have a lot. you connect to this Google Peering Edge with your on-premises router. Okay.
See the dedicated interconnect documentation for details.
So how do I connect my on-premises router to Google's GCP Google Peering Edge in a common colocation facility? This is the dedicated interconnect. Your on-premises router must meet the following. Normally, how far can I be from the colocation facility? Okay, so from the colocation facility, I still can be like some kilometers away. Okay. If your on-premises location is far from the colocation facility, use a partner interconnect.
Details on
Okay.
how to achieve these SLAs. In order to use dedicated interconnect, your network must physically meet Google's network in a supported colocation facility. This map shows the location where you can create dedicated connections. For a full list of these locations, see the link section of this video. Now, you might look at this map and say, well, I am nowhere near one of these locations. That's when you want to consider Partner Interconnect. Partner Interconnect provides connectivity between your on-premise network and your VPC network through a supported service provider. This is useful if your data center is in the physical location that cannot reach a dedicated interconnect co-location facility, or if your data needs don't warrant a dedicated interconnect. In order to use Partner Interconnect, you work with a supported service provider to connect your VPC and on-premise networks. For a full list of providers, see the links section of this video. These service providers have existing physical connections to Google's network that they make available for their customers to use. After you establish connectivity with a service provider, you can request a Partner Interconnect connection from your service provider. Then, establish a BGP session between your cloud router and on-premise router to start passing traffic between your networks via the service provider's network. Partner Interconnect can be configured to offer a 99.9% or a 99.99% uptime SLA between Google and the service provider. See the Partner Interconnect documentation for details on how to achieve these SLAs.
Cross-Cloud Interconnect helps you to establish high-bandwidth dedicated connectivity between Google Cloud and another cloud service provider. When you buy cross-cloud interconnect, Google provisions a dedicated physical connection between the Google network and that of another cloud service provider. You can use this connection to peer your Google Virtual Private Cloud network with your network that's hosted by a supported cloud service provider. Google currently supports Amazon Web Services, Microsoft Azure, Oracle Cloud Infrastructure, and Alibaba Cloud for use with cross-cloud interconnect. Cross-cloud interconnect supports the adoption of an integrated multi-cloud strategy and offers reduced complexity, site-to-site data transfer, and encryption. Cross-cloud interconnect connections are available in two sizes, 10 gigabits per second or 100 gigabits per second. First, you identify supported locations where you want Google to place your connections. Then you purchase primary and redundant cross-cloud interconnect ports. You also buy primary and redundant ports from your cloud service provider. After provisioning the connection, Google supports the connection up to the point where it reaches the network of your other cloud service provider. Google does not guarantee uptime from the other cloud service provider and cannot create a support ticket on your behalf.
Let me compare the interconnect options that we just discussed. All of these options provide internal IP address access between resources in your on-premise network and in your VPC network. The main differences are the connection capacity and the requirements for using a service. The IPsec
Okay, so with a VPN tunnel, we have a limited bandwidth capacity. Then we have dedicated interconnect and cross-cloud interconnect, which are kind of on the same page, I would say. They can arrive to 100 gigabits per second. And then we have the partner interconnect, which has a low limit of only 50 megabits per second, and then 50 gigabits per second. Remote VPN gateway connection in colocation facility or primary and redundant ports. Google Cloud, okay.
VPN tunnels that Cloud VPN offers have a capacity of 1.5 to 3 Gbps per tunnel and require a VPN device on your on-premise network. The 1.5 Gbps capacity applies to the traffic that traverses the public internet, and the 3 Gbps capacity applies to the traffic that is traversing a direct peering link. You can configure multiple tunnels if you want to scale this capacity.
Dedicated interconnect has a capacity of 10 gigabits per second or 100 gigabits per second per link and requires you to have a connection in a Google-supported quality. Gigabits links to achieve second capacity of person on the interconnect to establish between Google provider. Cross-cloud interconnect two sizes per second or 100 gigabits per second. If you need a lower cost solution needs or experimenting with you can choose enterprise-grade connection to Google Cloud. Choose dedicated interconnect to another cloud service provider. Google recommends using Cloud Interconnect instead of direct peering and carrier peering, which you would only use in certain circumstances.
Let's talk about the cloud peering services, which are direct peering and carrier peering. These services are useful when you require access to Google and Google Cloud properties. Google allows you to establish a direct peering connection between your business network and Google's. With this connection, you will be able to exchange internet traffic between your network and Google's at one of the Google's broad-reaching edge network locations. Direct peering with Google is done by exchanging BGP routes between Google and the peering entity. After a direct peering connection is in place, you can use it to reach all the Google services, including the full suite of Google Cloud Platform products. Unlike dedicated interconnect, direct peering does not have an SLA. In order to use direct peering, you need to satisfy the peering requirements in the links section of this video. GCP's edge points of presence, or POPs, are where Google's network connects to the rest of the internet via peering. POPs are present on over 90 internet exchanges and at over 100 interconnection facilities around the world. For more information about these exchange points and facilities, I recommend looking at Google's peering DB entries, which are linked below this video. If you look at this map,
wow. These are cables which connect regions like Monet, US, and Brazil. Let me see. Wow, look here. The Monet cable system is a SUSI fiber optic telecommunication cable completed in December 2017. Wow. "64 terabits per second. Angola cables. Wow, the Monet submarine cable investors. International Business Exchange Data Center. Wow. Okay.
App and say, hey, I am nowhere near one of these locations, you will want to consider carrier peering. If you require access to Google public infrastructure and cannot satisfy Google's peering requirements, you can connect via a carrier peering partner. Work directly with your service provider to get the connection you need and to understand the partner's requirements. For a full list of available service providers, see the links section of this video. Now, just like direct peering, carrier peering also does not have an SLA. Let me compare the peering options that we just discussed. All of these options provide public IP address access to all of Google's services. The main differences are capacity and the requirements for using a service. Direct peering has a capacity of 10 Gbps per link and requires you to have a connection in a GCP edge point of presence. Carrier peering's capacity and requirements vary depending on the service provider that you work with.
Now that we discussed all the different connections,
I want to understand. So my question is long and complex. I want to understand the difference between direct peering and direct interconnect in GCP. I suspect that one is done at layer 2, which means via cables, and the other one is done by only establishing a route between the on-prem and cloud routers. Is this correct? Not quite. Okay, great. So both direct peering and dedicated interconnect in Google Cloud involve private connectivity between your on-premise network and Google Cloud, but they are different in terms of implementation use cases. Dedicated interconnect layer operates at layer 2, data link layer. Physical connection. Yes, it involves a dedicated physical connections between your on-premise data center and Google's network. Description. You lease or install dedicated fiber optic circuits directly connecting your on-premises infrastructure to Google's network. The connection is terminated at Google's cloud interconnect location. Okay. Requires the setup of a cloud router to exchange dynamic routes using BGP. Direct peering operates at layer 3, network layer. No physical connection. This is an IP-based connection. Okay. You establish a peering connection between your network and Google. This happens over the public internet or a specific peering location with Google is present. You do not need to set up a cloud router. Instead, you agree on route exchange configuration. Use case, well, then I understood it well why it's saying not quite, but yeah, okay. If you need access to Google services with slightly less stringent performance requirements than dedicated interconnect. So physical via dedicated fiber, logical via IP routes. Latency very low but higher than dedicated interconnect latency. Bandwidth options from 10 gigabits per second to 100, typically lower than dedicated interconnect. Primary use, high bandwidth workloads requiring private traffic, access to APIs and services. High requires physical setup and configuration, low to medium. Misconceptions to clarify. Okay, this doesn't go to the over the public internet. It's a way to peer with Google networks over IP, typically, and internet exchange points or edge location without requiring dedicated hardware. Yeah, okay, I get it. I wasn't precise, but I think I understood it.
Connection services. Let me help you determine which service best meets your hybrid connectivity needs. We started this lesson by introducing the 5 different ways to connect your infrastructure to Google Cloud. We split these services into dedicated versus shared connections and layer 2 versus layer 3 connections. Another way to organize these services is by interconnect services and by peering services. Interconnect services provide direct access to RFC 1918 IP addresses in your VPC with an SLA. Peering services, in contrast, offer access to Google public IP addresses only without an SLA. Another way to choose the right service that meets your needs is with a flow diagram. Let me walk you through 3 diagrams using the assumption that you want to extend your infrastructure to the cloud. Ask yourself whether you need to extend your network for workspace services, YouTube, or Google Cloud APIs. If you do, choose one of the peering services. If you can meet Google's direct peering requirements, choose direct peering. Otherwise, choose carrier peering. If you don't need to extend your network for workspace services or Google Cloud APIs, but want to connect your Google Cloud network with other cloud services, Cross-Cloud Interconnect is the option for you. Cross-Cloud Connect is a Google-managed routing solution that is an ideal choice for workloads that need high bandwidth and need a Google-managed routing solution. If you're looking to simply connect Google Cloud VPC with another cloud service and have no high bandwidth requirements and want to keep your encryption managed by Google, choose Cloud VPN. If you want to extend the reach of your network to Google Cloud, you want to pick one of the interconnect services. Start with colocation facilities. If you cannot meet Google at one of its colocation facilities, choose Cloud VPN or Partner Interconnect. This choice will depend on your bandwidth and encryption requirements, along with the purpose of the connection. Specifically, if you have modest bandwidth needs, we'll use the connection for short durations and trials, and require an encrypted channel, choose Cloud VPN. Otherwise, choose Partner Interconnect. Within Partner Interconnect, you can choose between L2 Partner Interconnect and L3 Partner Interconnect. Choose L2 Partner Interconnect if you need BGP peering and L3 Partner Interconnect if you don't. If you can meet Google at one of its colocation facilities, you might jump to dedicated interconnect. However, if you cannot provide your own encryption mechanisms for sensitive traffic, feel that a 10 GEPS connection is too large, or want access to multiple cloud services, you want to consider Cloud VPN or Partner Interconnect instead. Google now supports VPN over interconnect options. After you have made your decision on the interconnect options, you can choose whether or not you want Google Managed Encryption. If you want Google Managed Encryption, choose the Cloud VPN over interconnect option.
Let's move our attention from hybrid connectivity to shared VPC networks. In the simplest cloud environment, a single project might have one VPC network spanning many regions with VM instances hosting very large and complicated applications. However, many organizations commonly deploy multiple isolated projects with multiple VPC networks and subnets. In this lesson, we are going to cover 2 configurations for sharing VPC networks across GCP projects. First, we will go over shared VPC, which allows you to share a network across several projects in your GCP organization. Then, we will go over VPC network peering, which allows you to configure private communication across projects in same or different organizations.
Shared VPC allows an organization to connect resources from multiple projects to a common virtual private cloud VPC network so that they can communicate with each other securely and efficiently by using internal IP addresses from that network. When you use Shared VPC, you designate a project as a host project and attach one or more other service projects to it. The VPC networks in the host project are called Shared VPC networks. Eligible resources from service projects can use subnets in the Shared VPC network. Shared VPC lets organization administrators delegate administrative responsibilities, such as creating and managing instances, to service project admins while maintaining centralized control over network resources, like subnets, routes, and firewalls. A project that participates in Shared VPC is either a host project or a service project. A project that does not participate in Shared VPC is called a standalone project. This emphasizes that it is neither a host project nor a service project. A standalone VPC network is an unshared VPC network that exists in either a standalone project or a service project.
VPC network peering, in contrast, allows private RFC 1918 connectivity across 2 VPC networks, regardless of whether they belong to the same project or the same organization. Now, remember that each VPC network will have firewall rules that define what traffic is allowed or denied between the networks. For example, in this diagram, there are 2 organizations that represent a consumer and a producer, respectively. Each organization has its own organization node, VPC network, virtual machine instances, network admin, and instance admin. In order for VPC network peering to be established successfully, the producer network admin needs to peer the producer network with the consumer network, and the consumer network admin needs to peer the consumer network with the producer network. When both peering connections are created, the VPC network peering session becomes active and routes are exchanged. This allows the virtual machine instances to communicate privately using their internal IP addresses. VPC network peering is a decentralized or distributed approach to multi-project networking because each VPC network may remain under the control of separate administrator groups and maintains its own global firewall and routing tables. Historically, such projects would consider external IP addresses or VPNs to facilitate private communication between VPC networks. However, VPC network peering does not incur the network latency, security, and cost drawbacks that are present when using external IP addresses or VPNs. Now that we've talked about shared VPC and VPC network peering, let me compare both of these configurations to help you decide which is appropriate for a given situation. If you want to configure private communication between VPC networks in different organizations, you have to use VPC network peering. Shared VPC only works within the same organization. Somewhat similarly, if you want to configure private communication between VPC networks in the same project, you have to use VPC network peering. This doesn't mean that the networks need to be in the same project, but they can be. Shared VPC only works across projects. In my opinion, the biggest difference between the two configurations is the network administration models. Shared VPC is a centralized approach to multi-project networking because security and network policy occurs in the single designated VPC network. In contrast, VPC network peering is a decentralized approach because each VPC network can remain under the control of separate administrator groups and maintains its own global firewall and routing tables.
Great. This was interesting, actually. I never investigated on these differences. Interconnecting networks. Which Google Cloud Interconnect service requires a connection in a Google Cloud colocation facility and provides 10 gigabytes per link? A connection in Google Cloud dedicated interconnect. What is the purpose of virtual private networking? To enable a secure communication method, a tunnel, to connect two trusted environments through an untrusted environment, such as the internet. VPNs are also called access. No, it is a method to detect intruders at the edge of a network. No, the main purpose is to encrypt data. No. Which of the following approaches to multi-project networking uses a centralized network administration model, shared VPC? If you cannot meet Google's peering requirements, which network connection service should you choose to connect the Google Workspace and YouTube? Carrier peering. Whoa. Let's go. We finished the module.
In this module, we looked at 5 different ways of connecting your infrastructure to GCP, which are dedicated
It
interconnect,
took a
partner
bit more
interconnect, cloud
time,
VPN,
but we
direct
did
peering,
it.
and carrier peering. I also gave you some guidance on how to choose between different services. Remember, you might start out using one service, and as your requirements change or new colocation facilities open, you switch to a different service. In this module, we focus on load balancing and auto scaling.
Okay, so this is already the next module. I will stop here. So I will continue this in the next video. I thank you for watching this video here, to be here with me, studying these kind of boring topics if they just took as isolated topics, but they will be cool when we will start building something that is actually funny, or I already have in mind some cool projects which involve maybe video games in some cases. For example, I was thinking if there's any way to allow two players to participate in the same game from different places on a server which emulates PS1. That would be so cool. I would love to play with some friends which now live far away from me. And I would like to invite them to play with me to PS1 games. I've never found an online server which allows you to play, for example, to Crash Team Racing. I would love to, to tell a friend, hey, just connect through a client, which allows you to send commands from your joypad and you just receive the same context as this player through the same client. So it's for sure a complex thing to realize, maybe also with a bit of money involved in it. But yeah, it will be cool to do it. So let's go. I will stop the recording here. Thank you for listening to me.